All right, so we've covered this a couple of times, right? What non-determinism is, and I did cover these in the slides that I made in the middle of the night, but let me just state them again. We're going to have a number in our tests. I'm going to start off by leading you through making a game with these players, right? There's a boss who his job is to give you the input. He's going to announce the input. There's going to be Pooh Bear with a very little brain. There's going to be a fairy godmother that's going to help you. There's going to be her evil sister who's going to try to fool you. As I said, the boss's job is to announce announce what the input is, and Pooh Bear is going to have to say whether it's a yes instance or a no instance. Each instance is, there's some language that we're trying to decide which, and each instance is either a yes instance or a no instance in Pooh Bear. Right, so poor Pooh Bear here. Well, right now I'm talking about non-deterministic polynomial time, just to give you a flavor for what we're doing. In that world, that Pooh Bear is limited because he only can work in poly time, right? And when the input is a yes instance, the fairy godmother is going to give him something to help him prove or to witness to his boss that it's a yes instance. And when it's a no instance, the no instance, the evil sister is going to try to convince you and the boss that it's a yes instance. And Pooh Bear is going to have to convince the boss. He's going to have to distinguish between these. He's going to have to verify whether or not the fairy godmother was lying. All right. So how does that work? Well, in all the non-deterministic problems, the yes instances, what makes them a yes instance is there exists some object that witnesses or proves the fact that it's a yes instance. And what is the fairy godmother going to do when it's a yes instance? There exists some object which witnesses it, and what she's going to do is she's going to provide that yes instance. She's going to provide that witness, right? On the other hand, and when the Pooh Bear gets the witness, gets the solution, he can quickly verify that it is a good witness, and hence he knows it's a yes instance, right? On the other hand, if it's a no instance, then it doesn't have such a witness, right? And so if the input's a no instance, she can't give you a good witness. Why? Because it doesn't exist, right? Does that make sense? So here, let me give you the classic example that Steve Cook, who I've written papers with, is proved was NP complete, non-deterministic polynomially, the hardest problem. It's the input is a circuit like this. So it's an and or not circuit with inputs being Boolean, true, false, and maybe the input also includes an assignment, right? So there's an assignment, and the question is, does this assignment satisfy this circuit, right? So i.e., is the output true? And what does Pooh Bear do? He says, hey, dude, I can do that, right? He can just percolate the answers down and see that it's a true, right? So in this case, he says, yes, it's a true. This assignment satisfies that circuit. Now, in this case, the fairy godmother wasn't needed, and there's no fooling anybody because Pooh Bear can do it all on his own, right? So now let's get a harder problem. This problem is the input is a circuit, but we don't give you an assignment, right? And the question is, does this circuit have a satisfying assignment, right? It's a search problem. So how many assignments are there? Well, they're in bits here, so they're 2 to the n possible assignments. So that's a lot of assignments. And poor Pooh Bear, remember, he only has polynomial time, right? So he can't check them all. And so he can't find the satisfying assignment. All right. But if it's a yes instance, right, if the circuit does have a satisfying assignment, then that means there exists this object that witnesses the fact that it has a satisfying assignment, right? What's the witness? The witness is the satisfying assignment, right? She gives it to Pooh Bear, and then Pooh Bear can check that it's a good assignment, right? Remember how the Pooh Bear can check it? It's a good assignment. It convinces the boss. The boss is happy, right? Everybody follow that? Right? But now let's suppose that the circuit is a different circuit. Here I changed that or to an and. Now there's no satisfying assignment, right? And so now the evil fairy godmother is going to want to convince people that it is satisfiable. And how is she going to do it? Well, if she does something completely different, then Pooh Bear will know that she's the evil one, right? So she tries to pretend to be the good sister, and she gives an assignment, right? But Pooh Bear can check it, right? He can check it, and he can see that it doesn't satisfy the assignment, so he's not fooled, right? Does that make sense?
Sir,
yeah.
For the fairy godmother, he's gonna come up with the assignment that's true. How are we supposed to somehow find the assignment somehow? Because
no,
or we just say that the fairy
story in which the fairy godmother gives it to you. All right. Okay. So we're just trusting the story right now.
Okay.
Right? So and so in fact, that's a big question. If you've ever heard P versus NP, that's the question of can this is an NP problem, because if you have a fairy godmother, you can solve it quickly. But the question is, can you solve this quickly without a fairy godmother? And the belief is you can't. The belief is there's no fast algorithm for this. All right. So now we're going to not worry about polytime. We're going to switch over to finite automata. All right. And these are new slides I made relating it to the problem we did before. All right. So what's true in finite automata is the boss is going to give you a very long input, and it's going to give it to you one character at a time. He's going to broadcast over the broadcaster the input. And Pooh Bear, he has a finite memory. There he is. Remember, he has a blackboard. There's his blackboard of a fixed size. And what can he remember on it? Well, he can only remember a little bit about the past characters, right? He's seen so many characters, he can't remember them all. And also, right, so that he could remember some information there, right? He also doesn't know anything about the future characters, right? He just doesn't know what's coming in the future, right? So those are two reasons why Pooh Bear is really disempowered, right? Does that make sense? Right. So right now we're just trusting the story. We're not worrying right at the moment how the fairy godmother helps, but let's just trust that what is she able to do? Well, she knows the entire input, right? She just knows it, and she's very smart. So she can help. But like we said before, she's only going to help when it's a yes instance. All right. And when it's a yes instance, and now the evil sister, well, she also knows the entire input, and she's also smart, right? And she's going to try to fool you on no instances, right? So both of these guys are going to try to convince you that the answer is yes, and you have to distinguish which sister is trying to convince you it's a yes, right? Because you have to say yes in this case, and you have to say no in this case, right? And remember, it's because there's some witness that the fairy godmother is able to give you. All right, so let's go to the concrete example that we have done in class, right? So the boss is going to give you a 0-1 string, one character at a time. And Pooh Bear has to say yes if it contains 0, 1, 0, 1, right? Now, remember I said that on the problems in consideration, each yes instance, there exists, for each yes instance, there exists some object that witnesses the fact that it's a yes, right? So what witnesses the fact that it's a yes instance? Well, what instances is a yes instance is you find the 0, 1, 0, 1, right? There's this long string and you just have to find the 0, 1, 0, 1 and say it's there. That witnesses the fact that it exists, right? And if it doesn't contain 0, 1, 0, 1, then there's no such witness, right? Does that make sense? Right? All right. Oops, what is that box coming in? I guess I haven't checked these slides so well. That box shouldn't be there. All right, so right, so what does Pooh Bear say? Well, as the inputs come, we have come up with the DFA for this problem. So we know it can be solved. He could remember something fancy about the input so far, but instead, he's going to just lay on the couch. That's what he's going to do. He's really lazy. He's going to lay on the couch and he's going to wait until he hears from the fairy godmother. All right. So let's build the machine that indicates what's happening. All right. How do you lay on the couch? There he is. Input comes. What does he do? He lays on the couch. It spirals around, right? Everybody good with that? And then, oh, there he is. That was him sitting on the couch. Well, it's kind of a jumpy couch. All right. Maybe he's not lying on the couch. Maybe he's bouncing on the couch. All right. So now what is the fairy godmother going to do? Oh, look at all these slides. Are kind of this one should be talking. She's talking, not her. Right. What's this the good fairy godmother going to do? He's going to kick him as soon as the 0, 1, 0, 1 is about to start. Right. He's going to let him sit on the couch. Then at some point he's going to kick him. And the way she's going to kick him is she's going to push him along an epsilon edge, right? She just pushes him. Now he's not on the couch anymore, right? All right. And now when he's off the couch, what does he need to do? Well, he needs to verify that the next characters are 0, 1, 0, 1, right? So that's what he does. Here's a little machine. He verifies, right? The next character is a 0, he moves along here. The next character is a 1, he moves along here. He walks along following the characters that the announcer is announcing, the boss, right? Everybody buy that? And then after he does that, well, he's happy. He knows it contains 0, 1, 0, 1. So what does he do? He gets back on the couch, right? And when he's on the couch, he just lets the rest of the input by. What's this thing here? That we didn't really need that. And this guy, she really should be talking to him. All right. Everybody good with that? All right. Now let's go back to the beginning again. Right? Oh, no, now we're saying, so if it's a yes instance containing 0, 1, 0, 1, she can convince him, right? And and so we're going to make this the accept state, right? And how does she convince him? Right? She pushes him along here. But now what about her, the evil twin, right? If it's a no instance, what's true about no instances is they do not contain 0, 1, 0, 1. And so she can't fool him. Right? So what does that mean? Pooh Bear, all right, I thought these slides were more exciting here, but all right, let's go on. So Pooh Bear, how is she going to help? Let's go back and see how she helps, right? The way she helps is she's allowed in our story, right? In our story, we don't have epsilon transitions. So in the first part of the test, I'm going to get you to write a story. And in the story, the way she helps is that without warning, she can erase some of his blackboard. She doesn't have to erase it all. She can erase some of it, and she writes something else on the blackboard. All right. So she's going to yell, "Get off the couch." Right. She writes it on his blackboard. And well, we know that what state, the states are only telling you what's on his blackboard. So if the contents of his blackboard changes, then that means he's changing states. And so effectively, she is pushing him from one state to another, right? So what am I saying here is when you're telling the story at the beginning, talk about her writing some message on his blackboard. And then when we convert it over to a machine, we're going to do it by putting in these epsilon edges, right? All right, so now the frustrated guy, he says, excuse me, what if we have this fairy godmother who's so useful to us, why can't she just put the answer on the board, right? If she can write on the board anything she wants, why doesn't she just say yes? Why? Anybody know why she can't just say yes?
She's not in charge, maybe, for that?
No, she can write yes. Will that convince the boss? Right? The boss doesn't know fairy godmothers even exist, right? So the boss won't be convinced. Because why? Well, because we were kind of implying that the fairy godmother can only help you when the answer is yes, right? When the answer is no, the evil fairy godmother is going to try to confuse you. And what's she going to do? She's going to write on the blackboard yes as well. And now Pooh Bear has to distinguish between, hey, who wrote yes on the board? Well, he can't distinguish. He can't convince the boss, right? Does that make sense? Right? Pooh Bear must distinguish between these situations. All right, so now let's define formally what it means for one of these machines to accept, right? So we have some string, any string. If the string is a yes instance, then what we need is that the machine can accept the input. And what do we mean by can? Well, we're saying it can have help from a fairy godmother if he wants, right? But the reason he can is because there exists the path from the start state to an accept state, right? That's how he can accept, because in order to accept, he needs to follow. There could be many paths, but he needs to follow a path that gets to the accept state, right? So there could be paths to reject states and paths that do lots of weird things, but there just needs to be at least one path to an accept state. And then the fairy godmother can show him how to get there, right? Does that make sense? Right? So that was the path that she told them to take, right? Everybody follow that? Right? There is a path. Remember what the path is? She says he sits on the couch, he gets off the couch, he verifies at 0, 1, he sits on the couch. That's a path, right? And if it contains 0, 1, if it's a yes instance, then it contains 0, 1, 0, 1, and that's our path. All right, but what happens if the string is not in the language, right? It doesn't contain 0, 1, 0, 1, right? Then the machine it can't accept, right? Even if there's an evil fairy godmother trying to make you accept, you simply cannot accept. And why is it that you can't accept? Is because there's no path to get there, right? Maybe you sit on the couch for a while, then the fairy godmother, the evil one, pushes you off the couch, and then you go for a while, right? But can you get all the way across? If you could get all the way across, then you would know there was a 0, 1, 0, 1, but there's not. So you can't get all the way across, right? So what happens if Pooh Bear is in this state here, and the next character that's announced is a 1, right? You'll say, uh-oh, there's no edge leaving here a 1. So we're going to just assume that he dies, right? That's Pooh Bear dying. You will like my Pooh Bear dying. All right, everybody follow that, right? So if there's not a 0, 1, 0, 1, he just can't get. He can busy wait here. The fairy godmother can push him at some point, but there's just absolutely no way for him to get over here and not die, right? Also, if suppose he got here and the input stopped, well, then he's on a reject state, so it'll get rejected, right? There's just no way for him to get here. Everybody follow that? All right. So how do we model this? Is we have a delta transition that says if I'm in a current state and I read some next character, normally a deterministic one, there'll be one next state that you're going to go to. But here there's going to be a set of possible states that you get to, right? You could, if the next character is a C, right? You could flow along here, or you could flow along there. And actually, maybe I should have added this to the slide. If there's also an epsilon transition here, then you would have a choice. You could take that epsilon transition. You could read the next character and go here, or you could read the next character and go here, right? Does that make sense? It's the Pooh, right? If there was an epsilon transition, I guess the way I write up the story in on the test is we're not going to have any of these transitions where C happens twice. Pooh Bear is always going to know which way to go. It's only with the epsilon transitions that the fairy godmother will push him. All right, so here, this is the same thing we had before, but it doesn't have an epsilon transition, right? From here, note the 0, with the 0, he could keep going here, or with the 0, he could go there. Right? Does that make sense? So that's the same thing he was doing before. And that's all I have to say about this problem. And this joke, this down here just says, right? God, hopefully God is a benevolent God. So she is going to give you a fair life. And what does a fair life mean? It means that there exists at least one reasonable path that you could follow from your start state to an accept state, right? If you're born and there's no path that you could possibly follow and succeed, then that would be unfortunate. So this is just saying what we've said before, right? A string is an accept state if there exists a path, right? And there may be many reject paths, but there's at least one accept path, and this witnesses the path is true, right? And here's this guy here. Remember, we said already, this one has no accept path. So the machine says no, right? And the language, right? This is the language accepted by the machine are those strings that contain 0, 1, 0, 1. All right, everybody follow that?